This is not just a machine, it's your creativity accelerator. Introducing ACCELaser HD1. It's born for making advanced laser tools accessible to everyone. HD1 expands your creative frontiers, breaking boundaries for you. Combine the abilities of two lasers. This dynamic duo effortlessly handles any materials. Powered by the all-new hybrid synchronized motion system, we've achieved large work area at ultra-fast speed. Equipped with high-speed LiDAR ranging and flying 3D galvo technology, HD1 boasts efficiency with instant micron-level accuracy. It delivers true, high-speed 3D engraving never achieved before. HD1 ensures pixel-perfect accuracy for diverse production needs with its dual-camera positioning system. What you see is what you get. HD1 is also compatible with Lightburn. Batch processing has never been so easy and efficient before. HD1 gives your home business more options and the ability to earn more. Want to elevate your creativity? With the optional add-ons, HD1 achieves flawless 360-degree surface engraving on 3D objects. Unlock the leap from 2.5D to true 3D engraving. Struggling with large-size projects? With the option of the conveyor feeder, HD1 further breaks through limitations in machine length. Need engraving and cutting in one job? HD1's innovative airflow switch ensures the clear cut you need automatically. Its fully enclosed design and multi-sensor safety system ensure comprehensive protection. Unlock limitless creativity with versatile accessories. With ACCELaser HD1, you don't choose between speed, size, or versatility. You get it all. This is not just a machine, it's your creativity accelerator. Introducing ACCELaser HD1. It's born for making advanced laser tools accessible to everyone. HD1 expands your creative frontiers, breaking boundaries for you. Combine the abilities of two lasers. This dynamic duo effortlessly handles any materials. Powered by the all-new hybrid synchronized motion system, we've achieved large work area at ultra-fast speed. Equipped with high-speed LiDAR ranging and flying 3D galvo technology, HD1 boasts efficiency with instant micron-level accuracy. It delivers true, high-speed 3D engraving never achieved before. HD1 ensures pixel-perfect accuracy for diverse production needs with its dual-camera positioning system. What you see is what you get. HD1 is also compatible with Lightburn. Batch processing has never been so easy and efficient before. HD1 gives your home business more options and the ability to earn more. Want to elevate your creativity? With the optional add-ons, HD1 achieves flawless 360-degree surface engraving on 3D objects. Unlock the leap from 2.5D to true 3D engraving. Struggling with large-size projects? With the option of the conveyor feeder, HD1 further breaks through limitations in machine length. Need engraving and cutting in one job? HD1's innovative airflow switch ensures the clear cut you need automatically. Its fully enclosed design and multi-sensor safety system ensure comprehensive protection. Unlock limitless creativity with versatile accessories. With ACCELaser HD1, you don't choose between speed, size, or versatility. You get it all. This is not just a machine, it's your creativity accelerator. Introducing ACCELaser HD1. It's born for making advanced laser tools accessible to everyone. HD1 expands your creative frontiers, breaking boundaries for you. Combine the abilities of two lasers. This dynamic duo effortlessly handles any materials. Powered by the all-new hybrid synchronized motion system, we've achieved large work area at ultra-fast speed. Equipped with high-speed LiDAR ranging and flying 3D galvo technology, HD1 boasts efficiency with instant micron-level accuracy. It delivers true, high-speed 3D engraving never achieved before. HD1 ensures pixel-perfect accuracy for diverse production needs with its dual-camera positioning system. What you see is what you get. HD1 is also compatible with Lightburn. Batch processing has never been so easy and efficient before. HD1 gives your home business more options and the ability to earn more. Want to elevate your creativity? With the optional add-ons, HD1 achieves flawless 360 degrees surface engraving on 3D objects. Unlock the leap from 2.5D to true 3D engraving. Struggling with large-size projects? With the option of the conveyor feeder, HD1 further breaks through limitations in machine length. Need engraving and cutting in one job? HD1's innovative airflow switch ensures the clear cut you need automatically. Its fully enclosed design and multi-sensor safety system ensure comprehensive protection. Unlock limitless creativity with versatile accessories. With ACCELaser HD1, you don't choose between speed, size, or versatility. You get it all. This is not just a machine, it's your creativity accelerator. Introducing ACCELaser HD1. It's born for making advanced laser tools accessible to everyone. HD1 expands your creative frontiers, breaking boundaries for you. Combine the abilities of two lasers. This dynamic duo effortlessly handles any materials. Powered by the all-new hybrids.
Hello everyone.
Hello.
Can you hear us? If you can, just drop some comments below. And tell us where you're from. I see some backers already. Mike, Pete. Hi. So glad that everyone is so excited about ACCELaser HD1. And I see many comments saying, I want one. It's insane. It's incredible. And we are so glad that you like the product, and we're excited to show you more here today. Australia, Spain. I know it's late night in Europe, so thank you so much for staying late with us. Colorado. Sweden, Florida. Great. So I think we are great to start today. And let's go through. Here with me is David, and I'm Rainy. You probably know me in the last live stream with Michael, and I'm responsible for marketing. So David is our CEO. He talked with Michael a lot.
Yeah, hi everyone. This is David, and I'm the CEO of ACCELaser, and I hope we have fun of this live stream. It's the first time I'm going on a live stream, so very excited for this experience, and we hope all together we will have fun together.
Yeah. Show some love to David. Okay, so let's see today's schedule. So we prepare a lot, and we would like to show you more of our product today. So basically, after this introduction, we will share the exciting news, the strategic partnership with JPT. And I think more than 6 backers or even more potential users ask what type of the laser source of the MOPA, 60-watt MOPA. And we hear you, and we increase the speed to negotiate with them and communicate with them. And yeah, we would like to share the good news with you today. And also we will show some big format wood engraving today. And also to share some product development updates and upgrades. And there's a good news for all backers. And also we have a special guest today, and I will introduce him right after the introduction. And lastly, and most importantly, everyone will have a chance to win ACCELaser HD1 Pro, and also free motorized riser base, which is worth $429 during the Kickstarter. So we are so excited, so let's get started. So first of all, the special guest everyone already know is Alex. So I would like to introduce him first. So hi, Alex, can you hear me? Or everyone already know is Alex. So I would like to introduce him first. So
Yep. Hi. How's it going? Sorry for the delay.
hi, Alex, can you hear me?
So Alex is
Or,
from Livestream
everyone
Giveaways.
already know is Alex. So I would like to introduce him first. So
Vector-rasters and
Hi.
MOPA.
How's it going? Sorry for the delay.
We are honored to have
hi, Alex, can you
here
hear me?
today and watch the live streaming.
Everyone already know is Alex.
Ask
So I would like
questions
to
for you guys.
introduce
Knows a lot
him
about
first. So
Got lots.
Vector-rasters
Got lots
and
for you.
MOPA.
How's it
And
going?
he
Sorry for the
is-
delay.
Yeah, we are honored to
hi, Alex,
if you
can
watch
you
here
hear
today
me?
and watch the live
Everyone
streaming.
already know is Alex.
And ask
So I would like
questions
to
for you guys,
introduce
his questions
him
and your
first.
questions.
So
Got lots. Got lots for you. How's it
Yeah,
going?
so let's go
Sorry
back
for
to
the
the
delay.
yeah. We're on
So,
the
hi, Alex.
if you watch
Can
here today
you
and watch the live streaming.
Everyone already know is Alex.
Ask
So I would like
questions
to
for you guys,
introduce
his questions
him
and your
first.
questions.
So,
Got lots. Got lots for you. How's it
Yeah,
going?
so let's go
Sorry
back
for
to
the
the
delay.
yeah. We're on
so,
the
hi, Alex.
if you watch
Can you
here today
hear me?
and watch the live streaming.
Everyone already know is Alex.
Ask
So I would like
questions
to
for you guys,
introduce
his questions
him
and your
first.
questions.
Yeah, it's mute.
It's mute. Okay. Continue. Okay.
PowerPoint.
PowerPoint. Switch to PowerPoint.
PowerPoint. Yeah.
Yeah. Okay. It has been a great experience working with GPT teams. They are very professional, and what amazed me is how popular GPT laser source is. A lot of users of our backer community shouting they want this laser source and want us to cooperate with them. And we hear your voice in our Kickstarter comment section and in our Discord, Discord community, Discord group. And yeah, we are happy to say that ACCELaser and the GPT is able to reach a strategic partnership. And yeah, this is last week. It's yeah, the image. Yeah, let's go to the Pepper. Yeah, let Pepper. Yeah, we invite Pepper from GPT to join our live stream today.
Yeah. So, Pepper, can you hear us?
Yeah. I can hear you. Can you hear me?
Yes. So, welcome, Pepper. Can you hear us? And he will introduce himself and also share with us what he thought about the cooperation.
Yeah. It's being now?
Yes.
Okay. Hello everyone. Good day. I'm Peffer from Shenzhen GPT, Optoelectronics. First of all, please forgive my not so good English speaking. I'm so sorry about that. Okay, it's a real honor to share a brief introduction about our company through this platform provided by ACCELaser. Let's start with GPT. We are a technology-driven laser source in the vector based in Shenzhen, China. GPT has always been focused on research and development and manufacturing of laser sources. Our core products include MOPA fiber lasers, CW fiber lasers, semiconductor lasers, solid-state lasers, and so on. We believe that through continuous technology iteration, laser applications will immediately move from industrial setting to every household. And ACCELaser's products exactly offer the opportunity to make this vision happen, which is why we value this collaboration so highly. When I first saw ACCELaser's products, I was really impressed with their innovative design. It's the first time I've seen laser tools integrating functions typically used in high-end industries like seamless penetration stitching, flying 3D cable, and so on. As a tech professional, I'm really eager to get my hands on this equipment, bring many personalized processing ideas to life through it. More importantly, GPT attached great importance to the laser tools market. We hope to listen to users through stream channels and work with our partner to quickly and accurately optimize our laser sources for more household users, so that our technology can truly serve drivers' daily needs. Okay, thank you for your time, and thank you for your support of GPT products. I look forward to work with ACCELaser to fulfill Kickstarter's rewards. Now, I'd like to pass the time to David for the next part. Thank you.
Thanks, Pepper. Thanks, Pepper. You are doing great. You are saying nice words about us, and yeah, thanks. And yes, yeah. You are doing great. You are doing great. And yeah, I see some comments that saying that we should be relaxed. Yeah, we will try. We will try to be relaxed because most of us didn't go on camera very often. So yeah, let's have fun together.
Yes.
And thanks, Pepper.
Yeah, thank you, Pepper. Thank you for taking the time with us.
Yeah, and let's go back to the PowerPoint.
See you.
See you. And okay, together.
Yes.
Thanks, Pepper.
Yeah, thank you, Pepper.
The image
thank you for taking the time with
hands
us.
with let's go back to the PowerPoint. General Manager Marvin.
See you.
And yeah, it's a great honor that for ACCELaser as a new brand enter to the market, having their partnership relationship. And yeah, actually talking with them and an interesting fact that I learned from GPT is their top manager are all engineers, which share a very good engineering culture. And yeah, the culture is rigorous and very the way they do things and be professional. They deliver the high quality laser source. Yeah, and working with them, we learned a lot. Actually, another fun fact is that coming from the diode market, some brands were saying their laser source as 48 watts or 45 watts, but GPT doing the opposite. While we doing our testing, they think they are 60 watt MOPA. They say this is a 60 watt MOPA, but so we test it is 65 and 66 watts. Yeah, this is a good lesson we learned from them. Building a good brand is about exceed. They say this is a 60 watt expectation, but so we not over promote. Is 65 and 66. Yeah, over promote. Yeah, this is a good lesson we learned.
So thank you for the good words. And
exceed. They say this is a 60 watt
so let's go to the next part.
And 66. Yeah, over promote. Yeah.
So now we will do some live demos and explain some techs with you guys. And I do believe that we have a lot of new technologies and maybe not all of you understand them all. And we have a really long Kickstarter page. So today we will explain some of them, and most of them are the key technologies, and we will help you better understand this product and what it's worth.
Okay. Yeah, here is how we're gonna do the following part. We were gonna to work through some key technology behind, and yeah, actually, what we try to convey is that for users, what you need to remember is what the message you need to get is you pay attention to yourself. What this machine means to you. It runs fast, it runs well, high quality, and it's easy to use. And yeah, these are three keywords to take away. But all those technology, sometimes technology is hard to explain. And also in this stage, we will try our best to explain our technology, give a glimpse of make those improvements make sense to the audience. Yeah. And this is a long PowerPoint. Talking with Rennie, we try to avoid like having a lesson. Okay, so we will have a Q&A during the demo, and we will having some technology explained and have some demo. Those demo are real life use case from ST, and I believe it's a popular use case. And we try to demo how those technology is related to you. And yeah, and Alex and the other audience, you can ask questions during the live stream, and we will look at the question and pause our when we are doing the engraving, we will we will answer all those questions you have. Yeah,
Yep.
yeah. Okay, let's get started. Okay. Yeah, a little bit about what's difference of our technology. We call it a hybrid synchronized motion system.
Yep.
Yeah, conventional engraver have gantry style.
Yep.
And the gavel style. Okay, and we put them together, and go beyond. This is the yeah. In the tool heads, we have a 3 axis. Yeah, in the market, there are gavels are 2-dimensional, and ours is 3-dimensional. It's actually a 3-dimensional tool head, and with the XYZ gantry in total, it has a 6 axis. Yeah, so let's watch the snip again.
Yeah.
This one, and let's see a demo. This one is popular. We made this video to demonstrate the capability of this machine. So let's watch them together. Okay, it's a short one. Yeah, it engraved in the curve surface, and yeah, it can go deep in the circle to print the pi, the pi number, and yeah, the pi number circle by circle, and in last it will engrave a pi image. Okay, and in the right, it can engrave in a very quick to like a jump between 2 steps,
Yeah.
which cannot be done by our dynamic focus point. Yeah, yeah. Hope all those make sense to you, and yeah. I want to go beyond that. I want to show some exciting parts with you. Okay. Seeing those in action, let's go back to the okay, this one. We have a 3 axis. Let me. Okay. 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 This one is fun, and I want to show you. This one. I'm not a tall person. This is my hand, and this is our component. This component actually connect 4 axes, U and U, V and W, and another move up and down. This component connect 4 axes. That's how we made it so small. In the industry, the dynamic focal module normally this size, and we managed to make it this small. When we do multiple iteration, and when we reach to this size, I'm super excited, and we do a lot of software parts, but the hardware, the mechanical part, this part is one part connect 4 axes, one component die casted. This is how we can manage to do this in an affordable way and efficient way, and also it's lightweight. Okay, you're moving this one is moving in the two heads. So the weight is very important. We will talk about the vibration, because in the high quality engraving, you need to control the vibration, compensate the vibration, and better you reduce the weight, the vibration source, the vibration is much smaller. The issue becomes smaller. And check this one. This is fun. I'm proud of this design, and I hope you like it. This is just start of the live stream. Okay, and I hope you're excited.
So this is the key component in the laser head. And to give some background information, David mentioned that U axis, W axis, V axis, that's another axis for the XYZ. So many backers or potential users, they don't know we actually have 6 axes in the head alone. So it's a really hard part for the hardware, and I think we kind of leading the design in this part. So we hope that you can understand the hard part of the design here.
Okay.
And it actually gives a lot of advantages of to the product.
Let's get back to this after the explanation. Let's watch this video again. That is actually a 7-axis motion. 7 axes, X, Y, Z, and U, V, W, and another motorized Z table. Double axis, double Y, triple Z. In total, 7 axes. We do this demo to show you the capability of this machine. We're gonna talk about software later, but this is the capability of the hardware and the motion system. Okay.
So that's why most professionals, I think, call it a game changer. That's part of the reason.
Okay, and let's go back. Let's continue about the. I want to point out some difference of our system. Okay, from the left is our hybrid synchronized motion. From the right is a section hybrid motion. Section it's obvious to mount a gavel into a tool head, and if you move slow enough, the tool head weight didn't mean that much, but actually the left and the right, even with the same hardware hybrid motion setup, different motion movement matters a lot. Just like the left and right is our machine doing the section engraving and the hybrid motion engraving. When it's like have you guys used 4-axis rotary or 4-axis rotary CNC? You can do 3+1 engraving, or you have a 4-axis linkage engraving. That's different. And if you have a 5-axis CNC machine, 3+2 is different with 5-axis linkage motion. It's totally different machine. Okay. And we put some additional information in the comment, in the pinned comment. You can watch the we share some links. Have you? At the beginning, there are a few videos to explain this technology further. We don't want to go too much detail here, okay? And yeah, pretty much. Okay, another key point. This section explains about the two dimension. So think about it. When you do the z-axis, we have a triple Z. A motorized table have a Z, and a tool head have the inside have a Z-axis, and we have a dynamics focal module is actually a Z, and the three of them moving synchronized, just like the left one. The left one is moving synchronized in 2 dimensions. Think about it in the 3rd dimension, and you can understand why our triple Z can move together.
Yes.
Okay, does that make sense to you? Okay.
Yeah, so that's crazy cool. And
Okay. So let's move to all those fancy tech norm. So how it affects our daily jobs. Okay, we find some popular item on the ST, and let's try. And the first one is the chopping board engraving. Okay, let's go to the, and also we decide to show you how I operate the machine directly. Yeah, we decide to show you the early stage prototype, and we partner for the software. We partner with Livestream, and the software the user will only need to learn the new software. Right now we are using command line and the control UI interface. It's not ready it's not ready yet, but I want to show you the early status so that can help you clean out the concern. Okay.
Yes.
Yeah.
So now David will prepare the chopping board engraving. So I think this is quite common.
This one
use
is a
case.
chopping use case, and we're gonna engrave an image this size, and we will have a close camera to show it in action, and I will operate. I will show you how I do the engraving. Yeah. Yeah.
So we will have a zoom in camera to help you see the details.
Okay. You can right corner. You can show my screen. Okay.
Okay. Yeah, and we will also show you what is going on the computer in the software. So this is the not the final UI. Is the developer version of the controller. And just like David mentioned, we are working with Livestream, and Livestream will be 100% compatible with ACCELaser. So this is the version we will show you here, only here.
Yeah, and I have done I have put the stock and set the origin, and yeah, we will have a dual camera system to after the software was polished, we will have a dual camera position system to position the workpiece. And right now I align the workpiece, and let's get started. Let's see in action. Yeah, and let me check. 420. Okay. Wish me good luck.
So the size of this use case is around 230 by 230.
Okay. This one is running the. Yeah, we will talk about it later about the Vector-raster engraving, and yeah, let's see in action. Yeah, and this kind of movement get the benefits both of vector engraving and the raster engraving, and it have the laser source active most of the time. You don't do much of the jogging, and you can see the sport size kind of like changing size is actually the gavel doing a very fast scanning. Yeah.
Yes.
Yeah, it's entertaining to watch the engraving. I hope you like it. Yeah.
Yeah. And actually, it's hard to achieve by other gantry laser machines because only the galvo can defocus like this and engrave the line with different widths. And we will explain that a little bit later as well.
How tight is the dial beams is going through we require the gavel? Yeah. Dave, you asked a question. So the dial beams, we have the laser source we're gonna talk about in detail later. But the laser source, the beam quality of the laser source is equivalent with the 20 watts in the market, which is one of the biggest achievement of our machine. You know what? When we launching this product, the market didn't seem to give enough attention to our diode laser. So today we will mainly focus on diode laser. So the diode laser kind of a misunderstanding in the market for a while is people get used to CO2 glass tube machine, and the advantage is cutting and especially cutting clear acrylic. But for wood engraving, the diode laser can engrave much darker and get a better effect, and also the maintenance is much easier, and the lifespan, I would say, for the I think there are two kinds of CO2 laser source. For the glass tube, you cannot do high details engraving. The small size and also the way it generates laser source, it cannot open and shut down in the high. And that's
it's done.
It's done. Okay. And yeah. Okay. I didn't put it in the center, but yes, this one took. Let me see. This one took
around 2 minutes.
This one took around, I believe, I don't, yeah, 2 or 3 minutes. 2 or 3 minutes. And normally, this kind of engraving, normally this kind of engraving took 20 to 30 minutes easily with traditional gantry machine. Okay. This is how fast this type of motion system. Yeah. And let's continue about the CO2. So CO2, the advantage of the diode laser is engraving. Actually, diode laser is for me is like a electricity car versus a fuel driving car. It's not a one superior than other. It's about your use case.
Yeah.
I hope that makes sense to you. And what we achieve a very high voltage and the in-depth beam quality is the most hard engineering task. So I think most people pay attention to the fiber MOPA, but actually diode is what our killer application. And let's go to that later. Okay. And this is the first demo. I hope you like it. Do you have a
Yes, the spot size. About the spot size, it's
showing the board. Yeah, I think it is an okay result, and I just checked the air pump. I think the air pump didn't go so well, but the speed is there, and this is the result. I hope you enjoy it. Yeah. Okay. That's the diode laser, and okay, this is the result. Okay, Ooh. So, sorry.
Yes, let's move on to the next part.
And yeah, do questions or yeah. And nice speed for dial. If the video engraving by it looks there is gaps. Yeah. And the quality is fine, but yeah, I think it's the air pump. I think it's the air pump. Yeah. Yeah. Always having fun in live stream.
Yes. Yeah, okay, let's move on to the next part.
Yeah. Okay. And yeah, this engraving show the speed. Normally, the motion system and this engraving took 2 to 3 minutes. Normally for gantry style, even very high end, high acceleration CO2 laser, it took far more time than this one. Yeah, and let's dive into some details. Yeah, and we have received a lot of doubts about too many new stuff and kind of too good to be true. And I want to give you a glimpse about how we made it and hope it can expand it a little bit and how those improvements over conventional machine will make sense. Okay. Okay. So this is a video clip we showed before, and this is the algorithm called Vector-raster algorithm. Okay, vector engraving is moving in the space, in the 2D space. Raster engraving is like moving back and forth. So this algorithm called the Vector-raster algorithm. And this demo was inspired by Chotech video. A link can be found in the pinned comment in the chat room.
Yeah.
Okay, they use defocus for the spatial graph, but ours cater to wide range of different use cases, just like we demoed previously, and this one. And yeah, this one, the left one took 26 seconds, and the right one took 5 minutes and 40 seconds. It's 30 times faster. Yeah, let's analyze why it can achieve this kind of speed. The first is the travel distance. The whole moving distance, ours, is much less than the previous one because in the previous, you need to have the over scanning distance. You need to have the distance for the gantry, for the machine to accelerate, reach the speed you want. And also when you have doing the raster, you will have some empty space you have to travel. At that time, you need to close the laser. So even with the same speed, same laser power, our speed is easily 3 or 4 times faster.
Yeah.
Okay, and not to mention our laser source is powerful. It can reach higher speed because of the power, and also the motion system can reach to 4,000 millimeter per second. Okay, and yeah, I hope that makes sense.
Let's move Alex a little bit down so we can see the comparison. Yeah, okay, that's okay.
Okay, so since it's vector rasting, where you work with Adobe, I think Lightroom can do most of the job. And yes, you can import the files into Lightroom. Yeah. The next engraving thing on a stand or something similar to give a close look. The screaming. Sure. Okay. The laser source for the UV. Okay, UV laser is a different laser source. It's good for engraving in the glass, and it's not good. It's not good for engraving wood. It's not efficiency. It's not efficient. Yeah. And yeah, thanks. So I seem nervous, right? Okay. When
Yeah.
we talk about Alex, yeah, sure, Alex, you can join and you can open your mic. Yeah, sure. You can interrupt me anytime. Yeah. So
Yeah, so we can continue to talk about the travel distance and also the speed.
so
I have a
Yeah, sure.
I just want to let you guys know I am writing down your questions that I see in chat as they're coming in. And I've got some particularly good follow-up ones too, so I will be circling back around to them. So even if these guys are busy hosting the stream, because they've got a lot of stuff to show us, I've got a full two-sided sheet. I'm gonna have to go get some more paper at this point. I'm taking lots of notes,
Great.
and I'm writing lots of questions down. So we'll get to all of them when these guys are done with their demos.
Great, great. Okay, great.
Yeah, that would be great too.
That would be great. And yeah, so we can have another demo. Let's do another real life job, a door sign engraving.
So this use case is the door sign engraving. So we see a lot of essay listings, and I think this is one of the most popular products on Etsy. And many small business owners also use this product.
150 and 50, right? See the.
And the size of this use case is around 220 by 113.
你改了原点吗 ？Okay, I gonna do the rehoming. Yeah, I gonna. Yeah, you can see me operate the machine because I see the homing position isn't right, so I rehoming the machine and doing the right the right Z height, and I believe all these will be when we finish, all this will be done by the machine automatically. And at this stage, why we didn't let Michael operate the machine is that we need to. Yeah, it's kind of like a software engineer, and at this stage, yeah, and still need to some trick behind, yeah. And let me show you. Confirm my setting. Confirm my setting. 150, 50, and 20. Am I right?
So let's see what you guys have questions. Yeah, I believe some of you mentioned the laser spot. So the laser spot size is different in the Pro and in the Ultra version. So
okay, ready for the second one. Is a door sign, and yeah, right.
Here we go. So we just started the engraving. So the spot size for Essential is smaller. It's like one of you mentioned. It's 0.08 by 0.06 millimeter.
Yeah,
and for the
yeah.
Pro and Ultra,
let's have some question, and yeah.
And it's a little bit bigger, 0.1 by 0.1 millimeter, both of Pro and Ultra.
Okay, it's in action. Can you see it working? Yeah, yeah. So we have a multiple strategy to doing the engraving. It will analyze the input files and find the best strategy fits, easy fits for the engraving and for best performance and for best results. Yeah, you can see sometimes it's doing the vector resting and sometimes it's doing the just raster. And we're trying to come up with algorithm that maximize this kind of setup, hybrid motion one. This is a new motion system. So normally when you have let's say I come from 3D printing industry, yeah, and we have done one thing that we ship out a machine from 2016 to 2017. 5 years later, we upgrade the firmware and the system boosted, the speed boosted, and that's how motion system matter. When you have a new hardware, you need to analyze the characteristic and optimize in the motion system, optimize in the software system, which Liban teams is very great. We're gonna collaborate with them and figure out how this motion system should be improved. So this the current state is fully this stage is like we having this style of a machine and we are optimized motion system and we are improving the software. It's gonna be better and better. The performance haven't reached its limits yet. Yeah.
Mm-hmm. So Jeff mentioned that please confirm the machine model this demo is on.
Okay, so the center stage is for Pro today. So enough attention to Ultra. Actually, we think the Pro version the Pro version is deserve more attention. Yeah, and also some use case, real life use case needs more attention, and diode laser need more attention because actually I would say we spend 80% of our time in diode laser. To be honest, yeah, and let's go. Will the higher end version Ultra need a cooler like CO2 since it's high power? Yes, and the Ultra version is the water cool, and we also have a good news to announce later for the Pro as well.
Mm-hmm.
Yeah.
It's
because it's high power. Without the water chilling, the cooling, the air cooling will how to say, it's like in the during the last live, okay, it's done. During the live stream, people will say the noise is like a jet engine. Yeah. It is for those much of heat distributed with air is very noise, and we optimized it and we decided it should be quiet, and so it's water chill. So okay, let's see the result. Okay, and yeah, cool. Okay. So can you see the work pics? Mm-hmm. Yeah. Okay. Yeah. And for the I see a lot of question about the air assist. Here is how we design the air assist. You know that we see this product is a design decision. Yeah. We can have a built-in air assist for the sake of the simplicity and for the convenience. But for a professional grade machine, you might want some flexibilities.
Yeah.
Because some users already have their like a big one, industrial one, and even the industry have evolved from the simple one to a 15 liter. The spec is bumped up, and you will want to have the flexibility to upgrade. Yeah. So what we design, what the philosophy behind is that this is a premium machine, and it's our flagship. And this one will need the flexibility. We will offer the flexibility instead of have a built-in air assist.
Yeah.
Yeah. I hope that makes sense to you. And yeah, the ACCELaser, the entry level ACCELaser is very affordable, but if you want to get the best result, you need to have a powerful one. But the powerful one doesn't make sense to there isn't one silver line or one solution for everyone. So we just design it in this way. I hope that makes sense to you.
Yes, and the add-on will also be available for you to add after the Kickstarter. So the recommended airflow is 30 liter per minute. Yeah.
Yeah. The water trailer is included for the Ultra. Yeah. And yeah. And yeah, I see some question about the camera. So the AI smart product recognition with the camera for batch engraving.
Yes.
Yeah.
Asked by CT.
Yes, I asked by CT. Yeah. I'm glad you asked, and I also want to share some of my thoughts. And I think it's a cool feature and a very interesting feature. And we have a dual camera, one in here and one in the tool head. And the I would say the lead camera, the lead camera is give you the rough positioning, and the tool head camera is very precise. We use this one to do the calibration. It's very precise. You can, having this dual camera positioning system, you can do the positioning and workpiece alignment and do all those hardware calibration for you without the manual. I'm gonna talk about that later. In the industry, the gavel, the dynamic focus module is very hard to calibrate. We nail it, and you just click the button and the calibration is done. I think that's how we use camera. For the recognition, I think it's a very interesting feature. We're gonna look at it in the future. The hardware is there. Definitely have the possibility because we have the dual camera, and we try to not talk about that in like AI or the that way. We won't talk. We won't use that norm for our product. Yeah.
Okay.
And I think for the batch engraving and some jigs or some pre-made some jigs will be much professional, much proficient for the mass production. And yeah. And yeah. When using the diode laser at half power, does it use less laser? Yeah. Yes. When you use half power, you consume lower, smaller, fewer power. Yeah. And that would be cool if the LiDAR depth data could be exported. Yeah, the machine could potentially use as a 3D scanner. Yeah. I see. I discussed this question with I think with user in the Discord group in depth. I think when it's very useful for one-time use, and I see the potential. I know what you are heading to. I think it's an interesting feature, and we're gonna explore and develop a dedicated accessory maybe in the future or for more premium machine. For this machine, it has a high speed ranging. We're gonna demonstrate this component later. It can measure at 50 hertz, 1 second for 50 points, and it can do reasonable measuring and 3D remapping, much faster than those physical probe. And but it was not meant to be 3D scan, because with 3D scanner, you have a dot cloud, and you have 1 second, you have maybe 1 million points. And our high-speed ranging is 50 hertz. It means 50 points. So you cannot measure very high detail one, but definitely you can measure some geometry. And if you are not worried about the time, it can do the job. Okay. And yeah, I hope that answers your question, Hiruda. Okay. Okay. With ACCELaser plan for the future, making more dual machine, UV laser or higher power fiber. Yeah, I see the potential of this motion system. You see different different laser source, different size for different needs. We can see a lot ahead in our
Yeah.
roadmap. Yeah, I'm pretty excited, and I hope more. Yeah, with the help of community, I think we can make it. Yeah, and yeah, and lowering the power will affect the depth of engraving. I feel the air assist is not working properly. There's is, yeah. I think so too. I think so too. The air assist is not working. Is a good shape. Yeah, yeah, you are right. Yeah, yeah.
Okay, so hope you enjoy this demo, and let's move on.
Yeah, yeah. We just talk about the dynamics focal module. I want to talk about the high quality motion components we use. Okay, a little bit about the dynamics focus module. We have one video in the comment section and pinned on the top. You can check it out. And a short introduction is that from the left image. Okay, let me see. Okay, so yeah, so the pen, can we see the pen? Yeah, okay. Okay, yeah,
Yeah.
okay. And actually the W-axis is moving these lenses, up and down. And the focal points here and here, it moves the focal points. Okay, and in this setup, you can change the focal points on the fly. Okay.
Yes.
If you have experience about CO2 laser, when you change your 2-inch focal length to 4-inch focal length, when you get 2-inch focal length, you have finer detail. And when you have a 4-inch focal length, you can cut deeper and have a nicer tolerance about the curved object. Like when you engrave in a tumbler, you switch to 4-inch, and you can tolerance more height. Okay, and these dynamics focal points will give us the freedom or privilege to change the focal length in real time. Yeah, if you I want to give you some hints about what we're going to do in future. If you're familiar with 3D printing industry, a tech called variable layer height.
Yeah, variable layer height.
Variable layer height, which was introduced by Pulsar, and it can reduce the print time a lot. And when you want high detail, you engrave in the high detail. When you want to do for some simple vertical object, you can increase the layer height. This one is interesting, and we're gonna explore in the future. And this dynamic focal module is an advanced technology, I would say, in the industry, and it's a little bit hard to use, because it's not that affordable and not that easy to use. They need to some expertise to calibrate the unit. Yeah, but we use the camera do it for you, and this one is interesting, and we like it, and we hope you like it. And
so that's actually the flying 3D Galvo feature we are talking about. And
yeah. A lot of people think that the flying 3D is meaning the 3D, like 3D scanning, no 3D scanning. It's what we want to focus is the capability to do the 3D engraving.
Yes.
It's at the current stage for this new type of motion system, what we want to focus. Because you see, when we build something, we build the hardware, and we have the firmware, and we have the software, one layer by one layer. Yeah, currently we are focused on the motion system layer. A lot of work ahead, but it's an exciting journey ahead. Yeah. I hope that makes sense.
Yes, and that's actually a step forward for other flying Galvo. So. Usually what we are talking about when we're talking about flying Galvo, that's 2D. So actually we can do 3D. So that's why we call it flying 3D Galvo.
Okay. So you can find a specific video talking about this technology in the pinned comment, or you can yeah, you can check it in the detail. I don't. Yeah, we're gonna answer some question and do another demo. Yeah, yeah. So when engraving over cone, each layer the lasers is in the spot focus. Yes, you are right. And yeah, and any longer focus point for engraving items that are deep with lips like a ball. I think the clearance and we want to say that 45 degree is easy for our machine, but we want to exaggerate about our spec. But our machine have a much tolerance than most of the machine. Okay.
On the market, yeah.
And on the market, yeah. And I thought, yeah. Okay. So let's get another demo about large format photo engraving.
Yeah, photo engraving.
Photo engraving. Okay, engrave in this wood stock. Okay.
And remember to stay with us. The giveaway will be after the demo demonstration. And so remember that our Kickstarter campaign is still on, and we have around 7 days left. And there are 3 versions. The essential is 20-watt diode laser and 2-watt IR.
Okay, it's running.
Okay, let's check it out.
And yeah, we're gonna talk about this technology is working, and this is another interesting algorithm. You can see is engraving stripe by stripe and stitching them together. And yeah, we call it seamless panelization stitching. Yeah, and the image was panelized, and yes, and just like the section engraving, we stitch them together, but seamlessly. And it's doing the machine is doing the engraving, and I trying to explain a little bit about the engineering task we face. Okay, so first of all, when we are trying to tackle this problem, you need to have a accurate motion system. You say when it's perfect, it can stitch together.
Yeah.
But a complex system like this, perfect is never possible. I would say perfect is never possible. Yeah, and so you have a multiple layer to address the question. You can have premiums, bearing, premiums, motor, and premiums linear rail. This is the hardware, and you can have great firmware. Motions like we do. We have multiple sensor and multiple compensation algorithm to make sure we measure the error, predict the error, and compensate the error. Okay, this is how we do it. And also in the software part, you guys know about the image R, right?
Yeah.
It's like a magic when you throw the image to the software, and the result getting better. So it's multiple layer engineering task. So what the task ahead of our engineering team is, you put a stock, you have input file, and a bump, it gets a perfect result.
Yeah.
Yeah, and I think we nail it. We nail the speed and we nail the quality, and yeah, it's still engraving.
Yes, and
Yeah.
you can see it's scanning strip by strip, so it's like sections
Let's see some
sticking together.
questions. Okay. And I understand correctly about the water cooling of the MOPA. Do you have to fill the water into the machine, or is there a hose you have to submerge into an external container? No external container is in the water chiller, but the water chiller is external unit, not inside the machine.
Yes.
Okay, okay. So Jenny, you're gonna answer how to enter the giveaway.
Yes, so when we start a giveaway, you just need to enter some keywords we give you, and then the tool will pick randomly one of the users who comment the keyword correctly, and that's the winner. So please watch the video live stream along, and we will start the giveaway after the demonstration.
Yeah, and the CO2 definitely win in the acrylic and in cutting. Yeah, CO2 laser is great. They are different, and the dial laser excel in engraving. It engrave darker and have a better effect because CO2 machine cannot close the switch that as fast as dial laser. It's just the limitation of the hardware. Okay, and so the engraving high definition image or engraving on wood, the dial laser excel. Yeah, just like I said before, it's just like an electricity car versus a fuel fuel car. Okay, and yeah, and CO2 especially used for clear acrylic. This is very important use case.
Yeah.
And for the wood, for leather, for most of the engraving, I would say dial laser doing better. If you compare with glass tube, is much better. Okay, and are there any hits problem or why he touches again the laser? I'm not sure I get your point. Okay, this. Okay. Are DWG files supported? I'm not. I think Livestream support those files. Most of the files. Okay. How fast the machine is? The gavel runs at 4,000 millimeter per second. For comparison, in the market, gantry machine can reach to 600 or 800. But you should notice that most of the time, machine have to accelerate to reach that speed.
Yeah.
So the speed is one important spec, but acceleration is making the difference because you see, for most consumer machine, the acceleration is 1,000 to 2,000, and our machine is 500,000 to 800,000. Yeah, yeah. It's totally different machine. If you want to compare the, okay. Let's not go into spec too much. Okay, and is the switch between dial and the fiber physical of the software. The switch is software control, and you can do it in one job, switching the fiber and switching the laser source.
Yeah.
And yeah. Is it possible to limit the angle of laser use the gantry only? Yeah, of course. When you do cutting, we have air switch nozzle, and when you do cutting, you don't want to have those angle too much. Okay. Does the machine have a lot of holes inside the machine, make the cleaning difficult? Yeah, the cleaning. What we're trying to minimize the maintenance. Yeah, and we want the protective lens. We want to design a air curtain flow to make it job by job or weekly maintenance to monthly maintenance. And the lenses for camera, and we still design the airflow for better maintenance experience. Those lenses need to maintain time to time, but with proper design, it can be minimized. We are striving to make that happen. Yeah. So this can cut wood and metal. Yes, this 80 watts fiber laser can easily cut 15 millimeter wood, and and the metal for a thin metal, 60 watt MOPA is capable machine to do that. You have been working a lot with Liban as the. Okay, so we are working with Liban, and Liban is a great team. Is a fun to work with them, and the user. I think the software is software. The community around the software is very important. Building another software for a premium machine like this one is not reasonable from my perspective, because as an engineer, we don't. From my standpoint, I don't want to reinvent the wheel.
Reinvent the wheel, yes.
And Liban built the best wheel. Okay.
Yeah.
Okay. Okay. Let's see the results. Okay. Okay.
Yeah.
So you guys see the results is image engraving, large format image engraving. I believe this one took about 8 to 9 minutes.
Yes.
But with Ultra, with a proper setting, it can reach to 5 minutes. 5 minutes for this one is almost took the whole workspace in the 300 by 400, I believe, or 500, 450. Yeah. I hope you like it. So for the clothes, for wood is this one is a simple task. You're never gonna find a stitching line.
Yes, you can't find it.
With zoom in and because wood is an easy task for our machine.
Yes.
Wood engraving is easy task. Wood task. We're gonna show another high definition engraving later, but I want to say that for wood is the first task we solved in the early stage. We didn't. The wood is relatively easy compared with other material. We want to show you the light using the diode, using the blue light to engraving a light sensitive high definition image on later. Please stay with us. Yeah. Okay.
Yes.
Yeah.
And glad that you like it. You like the result.
Yeah. For the gantry machine, I believe I think 30 minutes or
for other machines?
35 minutes or around 35 minutes, I guess.
You mean other machines?
Yeah.
Here.
52 minutes. 52 minutes. Sorry, 52 minutes. 52 minutes for comparison. 52 minutes. Yeah.
Yes.
Yeah. Let's get back to the question. Okay. Yeah, I think for those kind of job, some of the audience are more professional than us. You're doing it daily by daily and using your machine. How long it takes? Some people you can say this size of machine. How long? This size of the work, how long will it take for your job? And you can,
Yeah, I think Stickles 186 asked the question. So we use other machines to test, so that's around 52 minutes compared to the 8-minute job.
Okay. So I see some more questions. So for cutting, I believe last time we have seen the cutting, and this time we are mostly focused on engraving, and we want to make sure we make the point right every time, one by one. Yeah, and from the power, you can see some consumer diode laser. When you have a 40 watts, you can do reasonable cutting. Yeah, you can expect the same and much more power from our laser source, so it can cut faster. Okay. Yeah, can we see a 3D engraving? Last time we already see a 3D engraving. You see, well, because for this time, because a lot of user, we want to do daily job for our user and explain technology behind to make those improvements make sense to most of the user. So we're gonna leave away all those fancy demo we already done before, and you can check out
our YouTube channel.
Our YouTube channel.
Yes.
Okay. And do you have a letter? I believe we have done that before.
Yes,
yeah,
we
can
do.
check out our YouTube channel.
Yes.
Okay. Let's continue. Continue. So it already took 70 minutes. 19. Okay. Speed up a little bit.
Yes.
Okay. So we nailed the speed. So without the quality, speed means nothing because you cannot finish your daily job. What this machine is not a fancy machine for as a tool. It should be speed up your efficiency and save time for your family and have the more potential to make more profit. And let's try to explain why our diode laser is so crucial. I can literally say we put 80% of our energy to improve this diode laser.
Yes.
Okay. So about the laser source, we co-developer with this premium laser source. This one is I would say is groundbreaking is the word like I want to choose. Our laser source partner, they are fantastic, yeah, and leading the industry. Okay, we chose the right partner and the developer with them early. And let me show you what's the difference. It's very hard to.
Just a moment. Michael is online.
Hi, Michael.
Yeah,
Hi, Michael.
I see his comment.
Yeah.
Yes.
Yeah, nice to have you. Hi, Michael. Yeah. And and it's a pity that you are on the not able to join the live stream.
Yeah.
But nice to have you. Join us. Yeah.
Yes. Yeah.
And about the high quality laser source. This laser source I want to emphasize a lot because this diode laser is a brand new one. We are pushing the industry forward. And I want to explain the laser beam quality. This is one of the most important innovation of our products in the market right now. In the past few years, we go from 10 watts to 20 watts to 40 watts to 60 watts, even 70 watts. But the beam quality suffer when the power go up. You can see this kind of movement. Okay, we sketch the line here. The green one is suitable for engraving. Okay, above is not suitable for engraving.
Yeah.
It's normally diode laser is doing engraving much better than CO2. But when you reach the power to 40 or 60 watts, it suffer. The advantage disappear. So the typical workaround in the industry is, I believe if some of you own a diode laser before, if you have a 60 watts laser source, they will have give you an option to switch to 20 watts. Yeah. Does that make sense? Okay, and for some other vendor, they will give you a 10 watts for engraving and ask you to switch manually to do the engraving and cutting using different module. Okay, but it's inconvenience, and for our case, is no right. You see, because lower power means lower speed. When you can only use 10 watts or 20 watts, you cannot reach the high speed. So the power and the speed is a perfect duo of our machine. Okay, so the motion system innovate together with the laser source. Only that makes sense. You see why the industry didn't pay attention to this one, because when you have a system only move at the 500 millimeter per second, the much more power doesn't make that much sense. But when you can reach 2000, 20 watts is not enough. Okay, Okay, so I don't want to go too much about the beam quality
Yeah,
definition. So do you?
But Mike asked, is that because spot size increase with higher voltage?
Yes, yes. The spot size increase with high quality is the reason behind is beam quality and is a parameter called BPP, beam parameter production. Okay, is a parameter to measure the quality of the beam. Okay, the better beam, the better spot size, the higher energy.
Yeah.
Okay, so our pro and ultra beam quality didn't suffer when the power increase. Yeah, actually we pay a lot of effort to this one. Yeah, yeah, okay, okay. Yeah, yeah. Michael did a very fantastic video and flying to Shenzhen, and it's very pleasant experience with Michael. It brings us a lot of insight of how to build a machine, and we adopt a lot of them into into our further improvement. Yeah, yeah, and wax being label quality and HD1 low in the wax. Okay, okay. So
Yeah, that's the difference.
yeah, the beam quality, the smaller the number, the better the beam.
Yes.
Okay, the perfect Gaussian beam is one is the inferior, one is the perfect beam, and the smaller the number, the better.
Yes.
Okay. Okay, let's continue. And yeah, the short summary is that yeah, I want to emphasize let's give enough attention to the diode laser and this laser source. Actually, our motion system, our algorithm is our yeah, we're proud of, and this is the second most proud of component. But yeah, the whole attention go to MOPA, and MOPA is great, and we learn a lot of MOPA and its capability. But yeah, actually, I like that a lot. Yeah.
Yeah.
And for the quality, you have a good laser source, but you also have the optical systems to deliver the laser source to do the engraving. And I want to point out this is the image from Laban documentation.
Yeah.
And I want to point out for same laser source with the same incident light, we have the final laser spot. You see, the reason is because, okay, let me show you. Okay. Normally, when you have a Gavon machine, you need to, in order to get the field size, you need to have a large focal length. You can switch the focal length to the bigger one if you want to get a bigger field size. Yeah, and for ours, the focal length is like this one. Okay, okay. Does that make sense? Yeah. Very small focal length. So okay, very small focal length. Yeah. So the size we offer the best size in the industry is because of the hybrid motion. We don't need to put a large focal length so that we can reach much finer details. For the spotlights, because of the external laser, the optical system design, yeah, the laser source, which means, let me put it this way. When you have a 20 watts, Alex, you have a lot of experience in metal engraving. When you have a 20 watts laser source, you can drive maybe 150 or 100 field size to give enough energy density. But if you want to change it to a larger field lenses to reach larger workspace, you need to much higher wattage because of the spot size will increase. So the energy density will suffer. If you want to get a similar energy density, you need to increase the power, which means with the same power, with our motion system and optical design, it can reach it can make the power count. Okay, you can use low power for the better result. Okay, does that make sense?
Yes.
Okay. Okay.
Yeah, we can move on.
Oh, we can move on. Okay. A little lengthy. Let's move quickly. And so this complex system, you need to handle the mass and multiple component and the connection between component. The machine will shake. So okay, so this image is the left is image without the left is the image without the active vibration control. The right is with our compensation on. Okay, you can see the vibration here. See the vibration here and here. Okay. This is the same gantry, same machine, same test point, same test pattern. How we did it? We have ACCELameter in the tool head, and if you have familiar with 3D printer before, it will do some shaking to ensure its quality, and we have similar routine to find the machine's characteristic and predict the error and compensate the error. So this is how we manage to get the stitching right in the motion firmware level. Okay? Okay. I hope you like it. We have a multiple sensor and multiple algorithm to make sure the quality.
Yes.
Okay. Yeah. Yeah. Is it like an input shaper? Yes, you are right.
Exactly.
It's like an input shaper. Yeah, in the open loop and closed loop and etc. Yeah. Yeah. Why does he place his hand? Place the tumbler to be. Yeah. I just try to check the air assist work. Yeah. Because the first job doesn't look right for me. Okay.
Yeah.
Okay. Let's continue. Okay. This is the fun part. I want to all those lengthy demonstration. Let's see in action. And for most users, I believe you just see the result, and you just need to remember it's easy to use. You don't need to have a lot of experience about it. And for the fun part, we have a contest.
Yes.
I will prepare the.
Let me share some background. So you can see in the PowerPoint we have a link. So that link is actually the live stream Alex had with Michael. So they talk about our machine and his concerns about our machine. So we will put up the short clip of the live stream and what they are concerned about. And after that, we will show you our answer to his concern.
The first one is let's talk and during the engraving. This one is the first one. This one.
Hang on. Just show the.
Okay. Sure. Let's see the video first.
Yes.
Okay.
Yeah, and one of the things that I immediately thought of, and Alex, I swear you and I have talked about this before when we were many years ago. We talked about a Galvo that I think LMT had, where it was a large format Galvo that was on. It was a flying Galvo, but it worked in sections and it stitched things together. And I think that's how they've always kind of worked. It wasn't really a flying Galvo. It was, but it wasn't. And it would do blocks of the graphic at a time up to maybe 24 by 24 inches.
Yeah.
But there was always a problem with the images, the next section being stitched together.
And that's the crux. That's where I need convincing, because we've seen this before. This isn't a new idea. A flying Galvo has been a thing for a long time. And the problem with it is that if you don't have a fucking engineering degree, it's impossible to use correctly. So what are they doing to change that situation? This is where I need to be sold, because the vast majority of the people watching both of our channels, Michael, are not getting an engineering degree to use this laser. So how is this different? And why can people buy something like this with confidence? I know it sounds like I'm setting you up for a home run.
No, you're not, man.
I really want the answer to this question, because I don't understand it.
Yeah.
So what is different here?
Yeah, so that's the conversation Michael and Alex had last time. So we're here to show all of you and Alex the answer.
And and Yeah, what I'm gonna do is three job, one job 3 times.
Yes.
Yeah, the first one is for comparison. The first one is without the compensation, just stitching them together. The second one is with the compensation, etc. And the third one is I will deliberately make it uneven and make a slope and yeah, and have the LiDAR working for you. And we want to show LiDAR for you and how it works during this engraving job, and enjoy it. And yeah, the first one is for comparison, is just yeah, stitching them together. Yeah. Okay. Yeah. He said he's choosing to see it. Yeah.
Yeah.
Yeah. Yeah. Yeah, and you always get, yeah, this is the first time I on a live stream. I watch a lot of live stream. It's very fun to watch a live stream. Yeah. Yeah. I believe the machine isn't in its perfect state right now. Yeah, but I think it's okay. We can move forward. Yeah.
So this one is the casually put on the machine, right?
Yeah, I just put a light sensitive paper. We normally use those paper to test the accuracy, the precision. So this one, and we do photo engraving, high definition photo engraving to show the artifact. This one is to show the artifact without the compensation, without the compensation, without the bell and whistle, and just show you the how we manage to tackle the engineering task to make it easy for everyone to use. Okay, so the table is not that even. So let's get back to the engineering task. When you want to stitch perfectly, you have premiums machine move accurately. But another important effect is the stock, the workpiece. It's never gonna be that even.
Yeah.
Yeah, because the
Never
wood, the paper, and when you have heat, it will warp. I hope that makes sense, because yeah, in this scope group I discussed with Becker that they want to emphasize how important about the machine. Yeah, I share some thoughts that
Yeah, it's done.
yeah, it's done. Yeah. Yeah.
So you can see that there is actually lines between the strips.
Can you see this one?
So that's without compensation.
Okay. Can you guys see the artifact? Yeah. Give us a feedback, please.
Yes, that's obvious. The gap is obvious.
Okay. Okay. And this is high definition photo engraving. Okay. Okay.
So that's the comparison we want to show you.
And yeah, and I put another into the yeah.
Yes.
Let's get back to the homing position, and open those compensation. Yeah. Yeah. This is the second job. With this second job, I want to engrave the same image and
with compensation,
with
right?
compensation, with
Yes.
the compensation on, and there you see the difference. Yeah, as you can see, your backer, they have engineering degree. They want to. Okay. Okay. Longevity. Yeah, I see your point. Yeah, and I can see multiple optimization in different level for the hardware, for the sensor, and for the motion system, the firmware, and for the software. And yeah, in multiple sensor, I would say multiple sensor. You see, the accelerometer is the closed loop, and the camera is the closed loop, and I would say multiple sensor, multiple data, and in combine provide the error prediction and error compensation. Yeah. Can the red lines use for positioning, and does this? I believe when the product is polished, we want a single best workflow is dual camera. Yeah, because sometimes if you have a multiple choice, you get confused. But we always will have an option there when you are sure you want to use it. But the best workflow is it's kind of a different paradigm. You see, when you have a computer, you want the feature to be laid out. But when it's easy to use enough, when the software industry involved, when you have right now the iPad have the best user experience from my experience. Yeah. So I hope that answer your question. Yeah. And yeah. So the red dot, yeah, the red dot is there, and if you want, it's there, but we prefer the dual camera positioning system.
So why are we engraving the same image the second time? It's because we want to compare the results and show you the results.
No, he is saying that why he have multiple paths. You see, this is the multiple algorithm, multiple strategy we implement to make sure the quality. So it's one of the strategy we choose. We analyze the input and chose the right strategy to do the job.
Yeah. And what's the time difference?
Will be the time difference in time, almost no difference. Almost no difference. Yeah. As you can see, the laser just override. Yeah. People are guessing how we did it, and we like to share. Yeah, let's see the results. Okay. Okay. So this one. Yeah.
Yes. No stitching error.
Yeah, I can assure you with holding in hand and having a lens to zoom up, you cannot see the visual artifact. Okay, and this is the one without the compensation.
Yes.
Okay, can you see the two together?
Yes, this way is better.
Okay. Can you see the two together?
So that's the improvement we did.
Yeah. We like. Hope you like this one. And and this is how we claim that is for everyone. You don't need to the machine take care for you. The machine take care for you. You have multiple sensor and multiple algorithm strategy implement, and I believe it's very hard to find the is impossible for human eye. Yeah. Okay, and I want to add another task for this one. Is to
put the stock uneven.
Yeah. I want to demonstrate is this one. This one is 10 millimeter thickness, around half, one third inch, yeah, and one third inch, and ooh, and let's see how LiDAR work, and this one, and
So David is putting a wood with 10 millimeter width under the paper.
Yeah, it's important because you see in the real life use case, the wood is never be that flat. You buy wood from different sources, and with heat, with humidity, it will get warped, etc. And yeah, let's open the lid and let's do the bed level. Let's let the high speed ranging work. And yeah.
So
yeah. How it works is right now is measuring the table, and make sure it's yeah, it's just like the user mentioned before. It reconstruct the table. Yeah. Yeah. And with this intentional warp, we can still stitch them together. Yeah. And I would say normally for a wood, if you warp 1 millimeter, we can manage to do that. And with the slope, we can do that. That can handle, I would say, most of the situation. Yeah.
So after this demo and a few more minutes of the product update, we will go to the
it took about a minute or to measure the workpiece, and yeah, let's start the job. Yeah, let's see in action. Sleep now and you will miss the X. Okay.
Yeah, it's quite late in Europe.
Okay. Also are pretty damn good for free laser. And what does this mean? Sorry,
Alex, that's Alex.
Yeah, Alex. I didn't follow yet. No. Yeah. Yeah, 3 is early in your call. Thanks for your attention and thanks for your support.
Yeah. Right now, RN. Right now, family. Yeah. So I was just saying, like, if.
Okay.
So this one is also around 3 minutes.
Yeah, we using this demo, you can see in action of the high-speed ranging works. And when you put, let's say you have a skateboard, no skateboard, some curved object, some geometry curved object, you don't need a 3D scanner. You just use the high-speed ranging. You can choose. You can do the trade-off. You can measure every 1 millimeter, every 10 millimeter, and every 20 millimeter is up to you. But the higher the detail, the more time it consumes. So for this one, I believe we have a 10 millimeter per probe, and it can per second it can have 50 points. So it's pretty fast. Okay.
Yeah.
And yeah.
So these two questions are similar. I think what interval are the measurements taken, and how many points are getting measured per cm
square? Okay.
Yeah,
okay.
The interval.
Yeah, I believe it's 10 millimeter. Am I right? 10毫米每个。Never mind. I think it is fast enough. You can see the whole procedure. Yeah. Yeah. So and it's up to you to choose if you want high definition, and you spend more time. And if you are busy, you can do the raft. And I believe for wood, the raft 10 millimeter, 20 or 30 will be enough, because the tolerance, the whole algorithm implement, the tolerance is good enough. Okay. Yeah, maybe too large for skateboard, so it's just something came to my mind. Okay, and yeah, APL and input shaping. Yeah. Like I a little bit about me. I spent 7 years in 3D printing industry, and those technology will come from different industry, from other consumer sector. Okay, let's see the result. Yeah. So this is the setup, 10 millimeter slope, and the this wood is not perfect flat. We did not choose deliberately at all, and the light sensitive paper. And can you see the results?
Okay.
Yeah, 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 yeah. Cool. Let me know. Does that? Let me grab this one. Yeah. This one without compensation. And yeah.
Yes.
This one with the compensation. And this one with the slope and the compensation. Okay. This is the this is the most interesting part, and I hope you like it. And we already took 2 hours, so
Almost, yeah.
almost. So Discord image. So Alex, yeah.
But I think it's too long.
Okay. So okay. So I think we have a long enough demo. And
yeah. So we were thinking to get some images from our backers or also from Alex and do another random text to show you the results. But the live stream is already take a long time, so I think we can skip that part and go to the next part.
Okay. So yeah. Okay. So let's get back to the PowerPoint.
Yeah, and I hope this text answer Alex's question. So we actually use the LiDAR, the ranging system to scan the surface and then engrave the image.
So to summarize the whole structure, the points, first we nail the speed and we nail the quality, and we make it easy to use, make it out of box. That's what we achieved. And yeah, I hope you like it. And as an engineer, I having fun to tackling all those problems and having multiple sensor, multiple strategy to tackle those problems. Yeah, hope you like it.
Yes.
Yeah, and yeah.
So in summary, we would like to say that the machine is a very valuable one, and it actually brings concrete values to our users or small business owners. So like Michael mentioned, he hates to stand next to the machine and put the stock inside or exchange the stocks, and it takes time. So with the dual laser, it actually has fiber, infrared, and also dot laser. So it can change between laser source itself, so you don't need to change it yourself. So that's time saving. And also with all the technologies that speed up the process of engraving, it actually saves 4 to 10 times of the time when you're engraving your previous jobs. So that's one of the biggest benefits. And also it's space saving because just like I said, it's dual laser, so you don't need to put 2 machines next to each other and maybe engrave on this machine and then cut on the other machine. So that's space saving. So combined with all that benefits, it's cost saving. So especially with the Kickstarter price now, actually you can buy this machine with multiple machines functions and even more quality and better results at the price of one machine. So that's what we are trying to say. And always families are first, or even your time to spend on creativity or marketing is more valuable than standing next to a machine. So we hope these benefits of this machine can bring you all the value you need. Yeah.
Yeah.
So
and yeah, this live stream is all about real life object. We have multiple demos. They can be seen in the SD, and we do a high definition test just show you the capability of the machine, just like yeah, show you the capability of the machine. So let's move on. And exciting announcement, an amazing progress update. And yes, for the You see, for this machine, previously we designed it as an air cooling system, and yeah, as the development goes, and the air cooling system for the 55 watt, it has a lot of noise generate, yeah, and we will adopt adopt water chilling from the Ultra, bring it to the Pro for all users. It's a water cooling edit. It will reduce the noise level from the 80 dB to the 65 dB. Yeah, and yeah, just like previous live stream, that just like you said, 80 dB is like a jet engine. Yeah, and we will bring this to the Pro version. It's a water cooling system for Pro user, and I hope you enjoy it. And yeah, just like we have mentioned, we have announced before, all the Kickstarter backer will get a GPT laser source. Yeah, and I hope that make you happy about the MOPA laser source and happy about the Ultra. Yeah, that's the and
so that's the good news. So previously the Pro will not have a water cooling system. So now we added to the Pro. So all Kickstarter backers back the Pro can get that.
For the noise for the noise control and for the longevity of the laser source. Yeah, I hope you like it. Okay.
Yeah. So Alex, are you ready to ask some questions? It's the last Q&A part. So after the Q&A part, we will go to the lucky draw.
Yeah.
Yeah, Alex. We
I
took
have so many, and if I don't get to all of these guys, obviously we're a little low on time. But if I don't get to all of them, I am hoping.
Yeah, we can spend the time, and yeah, I believe we can take the time.
Yeah, and you can pick the top 3 first.
No, Alex, you choose the question. We're gonna answer most of the question. Yeah.
Okay. Cool. Thanks. Yeah, so one thing people want to see is demos of other models. Do you guys think that we'll see demos of other models before launch or even before the Kickstarter is over?
Demos, we demos Pro in the center stage, and for the Ultra, the most of the difference is power. Yeah, most of the difference is power, and we release multiple demos using the MOPA, and like we have a channel and the Discord having a Discord group having to receive the test request, and we will do the video and for snipper and share it in the group and share it in the Facebook group, and I hope that makes sense. And the 3 model have the same size. The same size and the same functionality, all those bell and whistle, except for the power. So for the Pro version, you have a 50 watts and 20 watts. It can do most of the job. And for the Ultra, it has 80 watts. It can do, I would say, 1.4 or 1.5 times faster doing wood engraving. And you guys know a lot about MOPA and the 20 watt difference. You tell. And for the essential it actually is not. It is what we design for Kickstarter community. It is more of entry and for maker, and not for their small business, or they just enter the business and try and test out. And this is how I believe most of the feature is the same. So we prefer to it's concise to deliver the message. When we design the product, we will try to be concise, and the main video can deliver the same message without, let's say, I can reduce the essential for dynamics focal module. At last, we decide make all 3 machines almost identical. Okay, just the power difference. Okay. Okay, the water cooler. Okay. Alex, continue.
What is the minimum and maximum depth of field of just the 3D module itself? What's the limit on that?
It's a design factor. I would choose not to disclose yet, but it's not a big one. But in total, it's 180, 180. And this spec you did not need to pay much attention because with our algorithm, you don't need to feel this one.
Okay.
Okay. It's you just feel it's a 180 millimeter. It's a large one. Mm-hmm. Yeah. Yeah.
With the motorized raster base.
With the without the motorized, it has 80.
Yeah.
80, around 80. Yeah.
Yeah.
Yeah. You don't need to pay attention.
What about the Motorized Z?
Motorized Z have additional 95 or 100, I believe 95, 100 millimeter. Yeah.
Yeah.
Yeah. The motorized table. Yeah. The motorized table is I think is a valuable add-on. It extends the table and
mm-hmm.
Yeah. Go ahead. Yeah.
延迟 some delay.
Yeah, some delay.
You showed the Vector-raster toolpath. That was very cool. It goes much faster. It's very similar to like a flood fill or an optimized fill.
Mm-hmm.
I'm wondering, can that be overridden so that like in Lightburn you can fill shapes or groups together? Because there are times where you'd want the beam to travel over a further distance in order to help keep the material cool. So is that something that you can override, or is that going to be locked in all the time?
Yeah. I think it is I think the philosophy will be like we hope to hide all those details from user and also provide the controllabilities for user. Livestream is a powerful software, and we definitely is doable, and we prefer to maximize and optimize for user. But if user wants, is a feature and an interesting feature. Yeah. Yeah, for my point, because
okay, so
because
the
of
would be on, but we consider like an override in the future. Got it.
Yeah.
Okay, sorry. There is a significant delay.
Yeah.
The 3D focus. Well, first of all, I should ask: Do both the blue light and the IR, do they both use an F theta lens for focusing, or is it a special lens?
No, because we have a dynamics photocal module. We can use this module to do the to do the flat engraving. So we don't have a F theta lens. We don't need a F theta lens. Okay. Voice.
Sorry, I'm just taking notes.
It's taking notes.
Okay, let's see. Next, your shielding on the machine when you pull the cover down and you're shielding. Are you guys getting that like tested and rated, or is it just colored?
The cover.
The cover. The cover can. We will pass a class 1 testing when we right now open the lid. You can do engraving, but when the product is finished, you cannot start the laser without the lid closed.
Yeah.
And we will pass the class 1 laser safety certification. Yeah, class 1 with the enclosure, and it can protect both the blue and the IR laser, 2 wavelengths protected. Okay.
Cool.
Okay. Yeah.
The diode laser doesn't use any fiber optics, right? That's all in the head of the machine.
The diode laser? No. Actually, the diode laser, and because of the Pro and you see the design logic is here. For the Ultra and for the Pro, the diode laser is so large and you are impossible to put it in the tool head. For 20 watts, for 40 watts, for other machine trying to make it 60 watt to put in the tool head will have a big issue because the tool head was too heavy, so the engraving quality suffer. Okay, and also with the big tool heads, you cannot make the machine compact. It's cumbersome, and the space was wasted. Yeah, so we put it in the remote area and use fiber to transfer those power to the tool heads, so the tool heads is lightweight. Yeah, in combined with our design, if we combine all those in the tool heads will much larger.
That's
yeah.
very interesting.
Yeah.
We already said no clear acrylics or glass. It's really not the right wavelength of laser for that, so we're going to skip that. You guys mentioned the spot sizes earlier in the stream. I'm just working my way down the list here. Stitching wise, so there's a couple questions. One, my colleague Kyle really wanted me to ask.
Okay.
Did you guys test stitching over a long period of time to see if there's extended consequences for running long jobs?
Yeah.
And is that something that needs to be tuned by the user? Do they have to go in and make adjustments, or is the software and hardware self-correcting?
Yeah, what we design, what we're trying to achieve is use it out of box and with pure maintenance as much as possible. So direct to this question, and it's a software self-corrected. For example, when from time to time, if you want to make sure it's in the perfect shape, you redo the calibration, okay? And the calibration will update those parameters, and your machine is good to go. When you move the machine to another space, yeah, like that, yeah.
Cool.
Yeah, I believe right now those components is mature enough. If you can use it for a long time.
Machine,
yeah,
you would redo the calibration.
Yeah. Yeah.
Height detection's LiDAR, we covered that, if you guys are wondering. Everybody in chat wants to know if you guys are willing to post photos of the things that you engraved on the stream today to like a Facebook page or something so that they can check them out in higher quality. Is that something you guys think you could do for them?
Yeah, sure. We can do that.
Yes.
And I believe the machine is not in its greatest shape right now, and we can share the image from the live stream, and we can do it better and for the comparison. Yeah, yeah.
Good. Yeah, cool. Is there going to be any rotary support? I haven't seen anything about rotary yet, and I haven't really heard a lot about it. Is there going to be rotary involved in this?
Yeah, rotary, we have 3 key component add-ons. One is the first one is riser base,
yes,
and the second one is rotary. Rotary for tumbler is very important. Yeah, even though you can do extend multiple tumbler in one go for the upper surface, but you still sometimes want to do 360 degrees engraving, and also for the 3D object engraving, this is interesting, yeah. And I believe rotary is essential for laser engraving, and also the conveyor system. We believe that some user want a larger area, and this kind of design we like it, and we will provide all those and additional accessory like a film extractor, external air pump, and even CO2 fire extinguisher.
Yeah.
We will plan in ahead and put all those design in mind, and we will when we ship out the machine, all those will be ready. Yeah. Yeah. The delay is
I'm
a
assuming
big
the bottom
delay.
of the machine opens because you have the extra motorized Z-axis you can put underneath it. Can you engrave straight through the bottom of the machine without anything underneath it? So like if I wanted to put it on this table and engrave something
Yeah, yes.
can I place the machine on the table and engrave it directly?
Yeah, sure. You see, for the logic is here because you have the conveyor system put in here, so the focus point is below the machine, so that you can operate the conveyor system. So if you want to engrave on your table, it's doable, but it's unsafe. Yeah, for the standpoint of passing the Class 1 certification, it's not a good practice. It's not a good practice, and we don't recommend. Yeah, but it's doable. It's doable, but not recommend. Yeah.
So possible, but not advised.
Not advised because this is we want the machine to be safe. Yeah, and yeah.
Yeah, I know that the file UI, just being able to use the machine, the user interface part of this is not complete. But I'm wondering, when it is complete, are files going to require pre-processing in a separate piece of software, or is it literally going to be a 100% Lightburn workflow from start to finish?
Lightburn workflow from design the file or import the file to Lightburn and control the machine directly through USB cable and through Wi-Fi. Yeah, and no preprocessor and no post processor. Yeah. Yeah, because we think Lightburn is already a great tool and the community have get used to it. Yeah. So a big delay. So you continue. Yeah, sorry.
Are you guys going to, again, we haven't really gotten specific about this, and if you're not ready to answer, that's okay, but are you guys looking at 3D file formats? Like if I have a really complicated shape, but I have an STL file for that, can I give that file to the machine to give it information about the varying depths and shape of what we're working with?
Yeah, we have actually we have done the rotary engraving demo like this one. Yeah, this one is actually AI generates 3D file and have the texture and do the engraving, and we have the STL and the 3D information. We coming from 3D industry, so this is by default. Yeah, this is by default. Right now we already can do that, and what we need to do is implement those in Lightburn. Yeah, and we have done that, and yeah. So this is a irregular shape, and having the 3D data you can do with the.
Next, I'm wondering, can you, and I know, again, this isn't done yet, but this is something that a lot of people are wondering. You walk me through the steps to run a job. Like, if I have a graphic and I want to engrave it with my ACCELaser, can you tell me from start to finish, what do I have to do to get it going? You know, am I literally just putting it in and hitting go, or do I have to provide certain variables in order to get it to work correctly? Where are we kind of at with that right now?
Yeah, what we are, I think is our goal can be achieved. Our goal is how you use your laser engraver right now is the same procedure. You open Lightburn, import or design file, and if you don't want to fine tune the parameter, you just generate and send it to the machine and go. Yeah, and import file, generate and go. Yeah. And the machine will take care of itself, and the software need to find the best strategy to fit your need. Yeah.
I'm seeing this again in chat, and I want to mention it because I have it written down somewhere. But someone's wondering, can we use both lasers in one job without having to like stop and then start with a new laser? So can I go right from using a blue light to an IR all at once?
You know what? You know what? You know what? Not only you can switch on light on the fly. We didn't promote that, but actually you can open the two laser sources at the same time. Yeah, in the industry, you have a reasonable use case for the copper, but in our use case, we still working on to finding proper use case. But the hardware is there. You can open two laser sources in the same time.
Wow.
Okay, okay. We didn't, but technology without application is useless. So we didn't want to emphasize that. Yeah. Mm-hmm.
That's very cool. Yeah. Cutting capabilities. Is there any integration with the dynamic focus? Because I could definitely see dynamic focus being useful when you're trying to cut things. Is that something that is worked into cutting right now?
Yes, yeah, you are asking a very interesting topic. And like I said before, the hardware is there, and the firmware and the software will improve the hardware. So let me show you a glimpse of the future plan. And yes, we have an airflow switch to get the airflow right, so you can cut with the airflow ready. And with the dynamic focal points, you can see with our metal engraving is already moved like this way, back and forth, back and forth, back and forth, to avoid the heat to warp the metal. This is the first one. You can do a large format cutting with a back and forth strategy to move the gavel. And yeah, this one is we already implement. And thinking in the z-axis direction, you can work like to up and down to improve the cutting capability. And also for multiple layer cutting, you can cut a layer and move down, and cut a layer and move down, and it will improve the capability to cut thick material. Okay, hope that makes sense to you. Okay. Yeah, the hardware will open a lot of potential ahead. We haven't implemented yet, but we want to explore.
That's amazing. So
yeah.
We officially have laser saws, guys. If you want a laser saw that exists now, I saw a user in chat.
Sorry,
ask, is there
Alex.
a gantry only mode where it would literally just operate like a normal gantry laser? Does that exist? Is that a functionality, or is that not something that's on the table?
Yeah, it's there if you want to, especially for cutting. But even for cutting, we optimize it. Is yes, you can let you make the gavel stand still. It will go straight down. Yeah, but even for cutting, we make it hybrid motion. You don't see it, but it actually is hybrid motion to improve the cutting. Okay. Because yeah, you can make the cutting faster. Yeah, it actually did make the cutting faster. Yeah.
Okay, sorry, the delay is actually 20 seconds, so I'm very far behind. For proprietary software, I'm seeing people have rumors in chat, they're talking about it a lot. Is there going to be an ACCELaser piece of software, or is it going to be Lightburn only? Is there going to be something that you guys have available for download to control this machine or do things outside of the scope of Lightburn? Or is it only Lightburn, there is no Accel software at all?
And yeah, we will. Yeah, we talk with Lab team closely, and we believe we will talk with them in Lab X meeting in person. And what I have in mind is pro light burn, and for a short period of time, we don't have a plan to roll out this kind of software. For long term, I will think about it, because if user is not for this premium machine, I believe Lighburn is way to go. In the future, if we have more entry level machine and the user just wants some more basic functionality, and the design philosophy is different, because Lighburn is like a complex software, yeah, and I believe some mobile first, or some more intuitive design might benefit the community. I don't see we don't have a timeline for it, but a cell laser studio, maybe a 3D model, yeah, and those components can benefit user. And but right now we focus on this our flagship machine, and cooperation with Lighburn teams, and I don't see another reason to not use Lighburn. Yeah.
Yeah, I think it's.
没关系。
Nice. Some people are wondering, how long is left on the Kickstarter? I think I heard you guys say 7 days. Is that right?
Yes, 7 days. So the Kickstarter project is ending on June 26th. So that's less than 7 days now. So if you're really you really like the ACCELaser HD1 and would like to get it at the best price, that now is the best time.
Yeah, this live stream, I want to talk more about the woodworking folks. Yeah, woodworking, metalworking, MOPA, and took the our, yeah. I think woodworking deserve more attention, and what we achieve in the dial is different, and literally we put more 80% of our engineering energy to the dial. This dial is different from others. Yeah. Yeah.
How long after the Kickstarter is over do people that don't get one have to wait for like a direct launch where they would purchase one from your website? Is that a big gap, or will it be shortly after?
Yeah, great question. So after the Kickstarter, we will launch a pre-order campaign on our own store. So people can still pre-order the product, but the price will increase a little bit. So the lowest price is still during the Kickstarter campaign. But if you are still on the fence and for some reason you cannot design before the Kickstarter ends, you can go to our store and pre-order them.
Awesome. We're almost done, guys. We've done this whole.
Thanks, Alex.
I just have a couple left that I've gathered from people as we've kind of gone through. This one's from me. Back to technical stuff. We're kind of going all over the place. Mm-hmm. Does the laser store files? Does it store jobs, or is the data streamed to it live from Lighburn?
Yeah, it actually has this machine is a powerful one. You have the capability to Wi-Fi connect, and you have the processors to handle to store the file, and to rerun the file, and we even will provide a mobile phone. It didn't have a screen of this laser, but we will have a mobile phone. You can see the status of the machine and mobile app, and you can get notification, etc., and control the machine and choose the previous done job, and this kind of experience. You use your mobile phone, or you have an unused mobile phone, you can have it just like this one. Okay, if you have an unused tablet, you can connect and put it on side of your machine, and it talk to the machine as an extended screen and help you to do the on-site working, without another computer,
And we run the job.
We run the job,
Nice. That's a cool feature. I like that.
Thanks.
Is everything on schedule so far as current Kickstarter backers? I know you guys have very specific dates listed on your Kickstarter. Are we still in line to meet all those goals on the timeline, or do you see any problems on the horizon?
Yeah, it's a challenging task for engineering. Here is our schedule. And next month, we will bring 2 machines to the Library X and meet Jason and Joe in person to make sure the software meets the when the software was polished and for when user get the hardware. And in the late September and early October, we will send our multiple machine to get. Rennie will host. We run a beta test program. And at this stage, some user will get some user will get their machine in hands, and we collect early feedback, software and hardware, and improve it. And hopefully, in the November and December, we can get most of our units ready. And this is our schedule. We're gonna show in 11x, and we can working on the software and the hardware, and we have a better programming to test those software, hardware, and let's see how it goes. We already spent more than a year, and we have multiple machine, and let's see how it goes.
And we are working toward the goal to ship all the rewards to our backers in November.
Can you give estimates for the lifetime of each laser source? So the diode or the MOPA, do you have lifetime estimates for those sources?
For the, I believe GPT MOPA laser source, you have more knowledge than me. It's directly from them. And for the 20 watt is a more mature one. 20 watt fiber, I believe, is a more mature one. For the blue diode, because it's innovative, we are on the edge of this laser source. For the normal laser source, I would say diode laser is more durable than CO2 laser and fiber laser because of its mechanism. And this one is a new one, and we're gonna lead the industry, and we're gonna test. Already we test a few dozen, and we're gonna test. I believe we need to test 100 before we ship out. And let's see. And I believe in theory, diode laser is more durable than CO2 glass tube. Okay, but different companies have different capability. We are trying our best to minimize the repair rate.
TBD, but good. I like it. We're on the bleeding edge. Somebody was wondering, does your ramp test, you did the 10 millimeter ramp with the stitching along the ramp along the x-axis, would that work along the y-axis as well?
Yes. It's actually a 3D map. No. You can put it in 45 angle. It doesn't matter. It's a 3D map. Any direction. Yeah.
Yes, nice and simple. Amazing. will the sources be user replaceable? So if a source goes out, can I swap it, or am I locked into the broken source and I have to replace the machine?
Yeah, definitely not replacing the machine. Here is how it will goes. And first of all, is replaceable for GRU user. And we already designed it in a modular way. So it's replaceable by technician of our training technician and some GRU user. But it's never gonna as easy as those scaffold laser because the system is simpler. Yeah. And we have to open the jack chain and undo some screw to finish the job. I think it's not as complex as CO2 mirror alignment, but those CO2 mirror alignment is a disaster for user. So what we prefer is we minimize the defect rate, and with small defect rates, we want to build a support system that we want to recruit some people in US and EU, and we train them and pay them to help us to do the repairment. And so user send the machine back and without sending them to the factory. So the machine is designed easy to repair by technician, not by consumer user, by technician. Okay.
Okay. Good to know. Yeah. Speaking of which, can we just talk a little bit about customer support? What kind of customer support are you going to offer your customers after they've purchased the machine? Do you guys have staff available to field questions or help work through problems?
Yes, we do. So there will be an online support team and also on-field service repair team. So the online team will communicate with users whoever have questions, and if it's about the product and after-sales issues, we will do some simple diagnosis online, and then we'll hand over to the repair team to do the on-site repair if it's necessary.
Okay. Yeah, it's
Awesome.
still we have
That's
a
cool.
lucky draw, and yeah.
Let's see. I'm almost done. We
Yeah.
only have a handful left here.
Mhm.
When you did the multiple, so I know we talked about this. We stopped because chat was asking some questions about it. You guys addressed it a little. But when we're running those multiple passes on like the photo engravings, I just want to make sure I understand this right. The reason it's doing those multiple passes is because like when you mow a lawn, right? Like when you cut the grass, you don't want the lanes of the grass cutting side by side. You actually like overlap a little bit. So that second pass is the overlap to actually stitch them together. Am I thinking about that correctly? I just want to make sure I understand it before I try to explain it to other people.
Yeah. This one, sorry about this one, Alex. I prefer not to go further about this one. What I can say is multiple sensor, multiple strategy, and trying to and the result is not human eye sees visual artifact, and I hope you can understand. Right now,
Okay.
our machine is still I hope to deliver high quality products as quick as possible. Yeah.
And the other thing I want to make sure I understand, so there's no, a lot of people are going to be like, I want CO2 for like the clear glass, the clear acrylic. But CO2 can not switch on and off fast enough to keep up with the motion control. Is that correct? Did I hear that correctly?
Yeah, for glass tube, no. For IF tube, I think it is. Yeah, for CO2 glass, CO2 laser is good for cutting and for clear acrylic. Definitely win, especially those are for cutting glass. CO2 is the one to go. You are good about this one, and you guys know this well. And because glass CO2 cannot engrave dark effect, so diode laser is doing great on engraving for most of the objects. And also the spotlights of the glass tube CO2 is the beam quality of glass tube is not good, but the IF CO2 can do better. Yeah, but right now IF CO2 is I would say it's not mature. It's not mature. So okay, for most of them, yeah, yeah.
Nice.
Yeah, I mean some very pricey premium IF tube is okay, but for other cheap
Gotcha.
one, the yeah.
That's my list. That's
Yeah.
all I've
Yeah.
got. I know a lot of people are asking questions while I was going through the list, but that's what I've got for today. So
Yeah.
I'm satisfied. I think the demos were really impressive, and
Yeah.
I'm really glad that you guys brought me on so that I could hang out with you today because I had a blast, and I'm very impressed with what I've seen. And
Yeah.
thank you guys in chat for your questions. I'll try to put this together into something a little more digestible down the road, but I don't want to delay these guys any longer, especially the Europeans. You guys probably having a hard time right now, but yeah,
Yeah.
this is very cool, man.
Yeah.
Very cool.
Yeah.
Thank you.
Thank you.
So
Thank you,
much,
Alex. Thank you. Yeah.
So that's so many questions answered, and there are more on the comment section, but time is limited, so we have to go to the lucky draw section. So that's the exciting part. So there are 4 prizes: 3 motorized riser base and 1 HD1. So we will draw for the motorized riser base first. So there will be 3 rounds for the motorized riser base. Each round have different keywords. So make sure you key in the correct keyword for it, so you can have the opportunity to win the prize. So the first keyword is 6-axis. So 6 in number, axis without space. So area, please enter the correct keyword. Area. Enter the correct keyword in the comment section. Yes, that's the one.
Without space.
Yes,
Yeah.
without space. 6-axis. And all lower characters. No capitalization. No capitalization. So let's show our lucky draw screen. So let's see how many people are in the lucky draw. So keep keying in so we can have you logged in the lucky draw tool. Yes, as you can see on the left side, that's and we have 132 entries now. So we are counting down to choose a winner. Ready?
First one is motorized.
Yeah, this one is for the motorized riser base. Ready? Yeah. So let's hit the button. And Aaron, make sure you screenshot and have the winner. The name of the winner is oh, it's Cinerum. Congratulations. Yes, so let's move on to the second one. The second motorized riser base, and the keyword is hybrid motion. Let's key in the second one, hybrid motion. And with space between these two words. Yes, Florida Man TV, you have the right keyword.
With the space in between?
Yes, with the space. Hybrid motion with space. Let's see how many entries. So we have more than 180 people with us now. And how many entries? Yeah, the keyword now is hybrid motion with space. So this is for the second motorized riser base. Make sure you key in hybrid motion. All lower character with space. Now we have 115 entries. Let's count down from 5, and we will start to choose the winner. 5, 4, 3, 2, 1, go. Okay, the winner is Martin. Congratulations. Yes, let's make sure take the screenshot, and we will move on to the next one. Congratulations. And then the final motorized riser base. The third keyword is Vector-raster. It's the algorithm we use to speed up the engraving. Vector-raster with space, all lowercase. Yes, Jeff P, you got the right keyword, Vector-raster. And thank you so much for bearing with us for almost 3 hours. And thank you for all the positive feedback. So we'll wait till we get 120, and we're almost there. Okay, let's count down from 5. 5, 4, 3, 2, 1, go. And the third winner is Sargon Tabor. Congratulations. So that's the all 3 motorized riser base. and our team will contact you afterwards. So the biggest price, the HD1 Pro, just key in HD1, all lowercase, that's the keyword. One with number, HD1. Now use the keyword HD1. And just to remind you, there are three models. The Essential with 20 watt diode laser and 2 watt IR. The Pro, 55 watt diode laser and 20 watt fiber. And the Ultra, 80 watt diode laser and 60 watt MOPA. And they're all available on the Kickstarter campaign. And that's the best prices. And except the Ultra, other models are still available with their super early bird prices. So make sure you check out our Kickstarter project after the live stream. And now we have 150 entries. We have more than 200 people watching now, so let's wait a little bit. Let's see who is the lucky guy or girl. Okay, let's count down from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's go. The winner is Bob Larson. I think I saw your comment. Congratulations.
Congratulations. Yeah.
Congratulations.
Hope you enjoy our machine.
Yes.
Yeah.
So thank you, everyone. Hope you enjoy the live stream. And it's David's first try on live stream. And thank you for your positive feedback and warm encouragement. And just the last reminder, the Kickstarter campaign will be ending on June 26th. June 26th. So it's less than 7 days. And we will comment the link under this live stream, and you can check out our campaign anytime. And if you have any questions, just shoot us an email at info@ACCELaser.com or comment and message us on Kickstarter. And we have a Discord server to communicate with our backers. And David is actually in the server and communicating with our backers deeply. So feel free to join us. And that's all for today. Thank you. See you.
Thank you.
And thank you, Alex.
Thank you, Alex. Thank you, Michael. Yeah.
This is not just a machine. It's your creativity accelerator. Introducing ACCELaser HD1. It's born for making advanced laser tools accessible to everyone. HD1 expands your creative frontiers, breaking boundaries for you. Combine the abilities of two lasers. This dynamic duo effortlessly handles any materials. Powered by the all-new hybrid synchronized motion system, we've achieved large work area at ultra-fast speed. Equipped with high-speed LiDAR, ranging and flying 3D Galvo technology, HD1 boasts efficiency with instant micron-level accuracy. It delivers true, high-speed 3D engraving never achieved before. HD1 ensures pixel-perfect accuracy for diverse production needs with its dual-camera positioning system. What you see is what you get. HD1 is also compatible with Lightburn. Batch processing has never been so easy and efficient before. HD1 gives your home business more options and the ability to earn more. Want to elevate your creativity? With the optional add-ons, HD1 achieves flawless 360 degrees surface engraving on 3D objects. Unlock the leap from 2.5D to true 3D engraving. Struggling with large-size projects? With the option of the conveyor feeder, HD1 further breaks through limitations in machine length. Need engraving and cutting in one job? HD1's innovative airflow switch ensures the clear cut you need automatically. Its fully enclosed design and multi-sensor safety system ensure comprehensive protection. Unlock limitless creativity with versatile accessories. With ACCELaser HD1, you don't choose between speed, size, or versatility. You get it all.